All right, welcome to Unit 3. We're going to be talking about factoring. We'll start by covering the greatest common factor and grouping. So, in last unit, we talked about distributing. So, for example, if we're trying to simplify this problem, A, we would distribute to give us 10x squared. We distribute to get negative 6x. And we would distribute to get positive 14. All right, we can do the same for B. Distribute, we get x squared. Distribute, that would give us negative 4x. Okay, or we could also distribute numbers and variables. So here, if we distribute all of this, we'd get 3x to the fourth. So remember, if we have power times, or a base times a base, we can add their exponents. That gives us x to the fourth. And then we'd get a negative 6x to the third, and then we would get positive 24x squared. Okay, so what we just covered is called distributing. Okay, but sometimes we have problems where we want to undo that distribution. Sorry, that has occurred. So this is called factoring. All right, basically undoing distribution is factoring. Okay, so there's many different types to factor. We're going to start, like I said, we're going to start with the greatest common factor, and then we will do grouping. And next time we'll talk about different ways to factor even further. Okay, so factoring out the GCF. A factor is a number that divides evenly into another number. All right, so we want to look at, for example, A. We want to say, what can we divide all three terms by evenly? Okay, so what is the largest number or variable that all terms can be divided by? All right, star, star, star. Please, if there is a leading negative, like for example in D, that's part of our greatest common factor, and that needs to be factored out. All right, so step 2 is we put that number or variable in front of a parenthesis. So we would maybe put a parenthesis around, and we put our greatest common factor in front. So looking at those three terms, we can divide all three of those by 2. Okay? After that, we want to divide each of the terms by the GCF. Okay, so we'll divide that by 2, we'll divide that by 2, we'll divide that by 2, and we'd end up getting 2 times 5x squared minus 3x plus 7. Okay, and if you kind of notice what we did for 1a, we end up getting the exact same solution. So again, we're just basically undoing the distribution that we did before. Okay, although we won't know what our answer is going to be. Okay, if you do this and you want to double check, you can always distribute and you should get the exact same answer. So that's always a way you can check. Okay, so pause and see if you can do B, C, and D. So looking at B, we'd put our parenthesis, we'd want to figure out what can we divide all four terms by. And you could maybe say 5. Okay, we can divide all those by 5. So we'll divide the whole thing by 5. We'd end up getting 5 times, well, 15 divided by 5 is 3, x to the third. And then negative 5 divided by 5 is a negative 1. And then negative 20 divided by 5 gives us a negative 4x. And 5 divided by 5 is just 1. Okay, and that would be your solution. Again, you could distribute that, make sure you got the same thing. C, okay, would make our parenthesis. What can we divide 27x and 30 by? We can divide them all by 3. So we'd end up getting 3 times, well, 27 divided by 3 is 9, and 30 divided by 3 is 10. All right. D, so I mentioned this before, if you have a leading negative, that's going to be part of our greatest common factor. So we'll take out a -1, and then we'll divide everything by a -1. So we'll have -1, parenthesis, negative x squared divided by a -1 just changes its sign to x squared. 3 divided by a -1 gives us a -3x, and then a -4 divided by a -1 it'll be a +4. Okay? And you don't need to keep the 1, you could just have it be a negative. Okay? Alright, whatever helps you. Okay, next. So these ones are the same sort of thing, except we will be taking out, the GCF is going to be our variable. Okay, so how many variables, how many x's for A can we take out? Alright, well there's 2 x's, this is like x times x, we have 2 x's here, and here we have 1 x, so we can only take out 1 x from both of those. Okay, so our GCF is going to be an x, and then we'll divide it by an x. All right, and we learned about how to exponents what to do with exponents when we're dividing. So x to the x squared divided by x, well, we subtract their exponents. So this would be the same as x to the 1. So 2 divided by 1 gives us 1, so we'd end up just getting an x. And then x to the 1 divided by x to the 1, or just x divided by x, is just 1. So we'd just have -4 times 1, which is just -4. Okay? One of the trick thing is that our GCF for our variables will always be the smallest exponent. Okay? If we have a problem that's like x squared minus 4x plus 2, okay, this would be our smallest term, and there's not any x's there. We wouldn't be able to take any x's out. We couldn't factor out a GCF for this kind of problem, okay, because there's not a number that we can factor out, there's not a variables that we could factor out. That would be, for what we've covered so far, that would be the biggest, would be finished, okay? So just remember, greatest common factor for the variables is going to be, if it's in standard form, it will be the thing that's the most right. Okay, smallest exponent. Okay, so example B. Looking at that, how many b's can we take out? Okay, there's 3 b's here, there's 2 b's here, and there's only 1 b here. So we can only take out 1 b. So we'll take out a b, we'll divide by b, would end up having b times 3b squared plus 2b minus 4. Okay, just again, basically we have 3 b's and we take away a b, that leaves us with 2 b's. Here we have 2 b's, we take away 1 b, we only have 1 b left. And if we only have 1 b and we take away a b, we have no b's left. Okay? All right, C, same sort of deal. We can't factor out a number. There's no numbers that would divide 8, 2, and 7, except for 1, which doesn't really help us. For variables, we want to, again, I think I've mentioned this before, maybe I haven't. We always have to have things out in standard form. Okay, so this C is not in standard form. We would want to do 2m to the 8th first, and then we'd do plus 8m to the 6th minus 7m to the 4th. Okay? So once we have that, then we can go and factor out the GCF. So GCF for here, the smallest exponent would be m to the 4th. So we will multiply it by m to the 4th and divide it by m to the 4th. Would end up having m to the 4th, okay? And then 2 times, all right, 8 minus 4 gives us m to the 4. 6 minus 4 gives us m to the 2nd. And then 4 minus 4 gives us 0. So we'd end up just getting minus 7. And then D, greatest common factor. It's in standard form, okay? So first thing will always be, number 1, standard form, and then after that we'll always check and see if we have a GCF. Always, for the whole unit, okay? Standard form first, GCF. And a leading negative includes the GCF. Includes leading negative. Okay, so for this one of my students asked, well, do we need to take out a negative? Okay, well, we're just talking about the most, like if it's in standard form, our leading negative would be something that would always be at the very front. Okay, so here we don't have a leading negative, but we can take out a y from all 3 of them. It's our smallest exponent. So would multiply and divide by y, would get y times 5y to the 5th, so 6 minus 1, 3 minus 1, that would give us y squared, and then y, 1 over 1, ends up giving us just a negative 1. Right, and then here we're combining, or we're using both numbers and variables. So for this one, we'd look and say, what's the greatest common factor for the number, for the coefficients? And you'd say, well, that would be 2. And then for the variables, that would be our m to the 6th. So we'd divide it all by 2m to the 6th. We would get 2m to the 6th in the front. 8 divided by 2 gives us 4. 8 subtract 6 gives us m squared. Negative 2 divided by 2 gives us a negative 1. And 6 subtract 6 gives us 0. M to the 0 is just 1. Okay? So we just end up having minus 1. And if you wanted to check, this would be a great time to distribute and check and make sure you end up getting the exact same thing you started with. B, okay, standard form, we have 5, 4, 3, perfect. We have a leading negative. So what would be the greatest common factor for the numbers? Oftentimes it's their smallest coefficient. Sometimes it's not, so make sure you check. But for this one, it would be 2. And since it's a leading negative, it would be a negative 2. And then the smallest exponent would be x to the 3rd. So negative 2x to the 3rd would end up getting negative 2x to the 3rd. And then in the parenthesis would do negative 6 divided by negative 2, which gives us a positive 3. 5 minus 3 gives us x to the 2nd. Positive 2 divided by negative 2, that gives us a negative 1. And then x to the 4th over x to the 3rd, that gives us x. And then negative 10 divided by negative 2 gives us a positive 5. And x to the 3rd over x to the 3rd cancels out with, and that leaves us with a 1. So 5 times 1 is just 5. All right. C, so pause if you haven't tried this on your own. These are in standard form. Okay. Greatest common factor for the numbers would be 3. And for the variables, it would be our smallest exponent, which would be x squared. So we divide everything by 3x squared. Okay. So it would end up having 3 divided by 3 is 1. 4 subtract 2 gives us x squared. Negative 2 divided by 3 gives us a negative 2. And 3 minus 2 gives us 1, so x to the 1, which is just x. 24 divided by 3, that ends up giving us positive 8. And x squared divided by x squared gives us, they cancel out. Okay? Again, you could distribute to make sure you got the same thing. All right, this is where a lot of students had mistakes when we were doing the notes. This isn't in standard form, so your intent, you're thinking, well, my greatest common factor is going to be a negative 9, because it's our leading negative, and you can divide everything by 7, okay? But this isn't in standard form, so we would need to write it in standard form first, so 21 y to the 7th plus 7y to the fifth minus 7y to the fourth. Okay, looking at that, we don't need to take out a negative for our GCF. We just only want to take out a 7, and our smallest exponent would be y to the fourth. So in our answer, our GCF is 7y to the fourth, and then everything else, so 21 divided by 7 gives us 3, 7 minus 4 gives us y to the third, 7 over 7 gives us 1, and 5 minus 4 gives us y to the 1, and then negative 7 divided by 7 gives us a negative 1, and y to the fourth divided by y to the fourth is 1. So that'd be like 1 times 1, which is just 1. So we'll just leave that like that. Okay, if you have any questions on how to do that, let me know. We're going to go on and do factoring by grouping. Okay, so when you're given a problem that has 4 terms and we're asked to factor, you may want to consider using grouping. Okay, there may be ones where on a quiz, homework, or test where they may just say take out the greatest common factor, and if that's all they're asking, you don't have to do anything else. Okay, but these ones, they're going to ask us and say factor using grouping. Okay, so there's steps over here. We won't read that together. We'll just get started with some problems. So the first step is to separate it into 2 parts. Okay, in effect, we have 2 terms on the left and 2 terms on the right. So what we're going to do is we are just going to do the GCF of the left side. So looking at that for the numbers, we can take out a 4. We can divide 4 by 4 and 20 by 4. And we can also take out an x. This would be our smallest exponent, so we can take out an x. Divide it also by 4x. We'd end up getting 4x. And then what we have left, so 4 divided by 4, that just gives us 1. And 2 minus 1 gives us x. 20 divided by 4 gives us a positive 5. And x divided by x is just 1. So we'd just be done with that. Okay, the right side, we do the same sort of thing. We have a leading negative, so we'll factor that out, a negative 3. For the variables, we can't take out an x because there's only an x on the left side, left term, but we do have a y for both of them, so we can factor out a y. So we do minus 3y. And then when we divide everything by negative 3y, we'd have negative 3 divided by negative 3. That leaves us with 1. We have y divided by y. That also gives us 1. So all we have left would be an x. And then we do negative 15 divided by a negative 3. Well, that is a positive 5. And y divided by y is just 1. They would cancel out. Okay, so we'd end up getting this. What do you notice in the parentheses? They are the same, okay? So, and that is how it's supposed to be. If they're not the same, then you probably made a mistake and you should go back and double check. Perhaps you didn't factor everything out for the GCFs, okay? So since these are the same, these are basically our new greatest common factor, we can factor that out. So in effect, kind of like in a long sort of way, we can put this parenthesis around, we can do x plus 5, and then we can divide everything by x plus 5. Okay, so 4x times x plus 5 divided by x plus 5, well, that would cancel out. And then negative 3y times x plus 5, divide that all by x plus 5, and that would cancel out. So in effect, we have x plus 5 times what's left. So we have 4x minus 3y. Okay? So that's kind of like the same thing we did before when we had two terms on that side. Now we have 2 terms. Okay? And we just do the same sort of thing. All right, I'm okay if you just, this is one of the things I told the students, okay, as long as you know what you're doing, okay, we can just factor this out, would have x plus 5, and everything else will go in our other parenthesis, so 4x minus 3y. And that would be our answer, okay? So as long as you understand that's what we're doing, we're just factoring out that x plus 5, and then whatever's left will go in another parenthesis. Okay, so B, same sort of thing. Cut it in half, would do our GCF. Okay, we can factor out a 3. We can also factor out an x squared. Okay, would end up getting 3x squared times, so 3 divided by 3, that gives us 1. And then we have 3 minus 2, that ends up giving us x. Negative 6 divided by 3 gives us a negative 2. And x squared divided by x squared ends up just giving us 1. So we just get x minus 2. All right. Other side, greatest common factor here would be 15. So we can divide it by 15. Would get plus 15 from here. And then 15 divided by 15 is 1. So we'd have x minus 30 divided by 15 gives us 2. So again, you notice that we have what's in these parentheses are the same. We can take that out, x minus 2, and would end up with 3x squared plus 15. Okay? All right. So we haven't combined using the GCF. So if some of these problems, we can also take out a GCF. But we're just going to focus on just do the grouping. We can worry about taking out the GCF while we're doing grouping later. Okay, so for example, here, since we have a 3 and a 15, we could factor out a 3. We get 3 times x minus 2, and then would end up getting x squared plus 5. Okay, and we could even factor further, but we haven't covered how to do that yet. So let's just stay to this point for now. All right, so pause and see if you can do some of these by yourself. I'm going to go over all of them, but it'd be nice if you could try it by yourself. Okay, cut it in half, GCF. Okay, so the GCF is going to be, for the numbers, we could take out a 4. And for the variables, we'd use our x squared. So we'd have 4x squared, and then what we have left in our parenthesis would be x, because we cancel the 4's, or 4 divided by 4 is 1, and then 3 minus 2 gives us 1, so x to the 1. And then 8 divided by 4 gives us positive 2. And then the x squared over x squared just gives us 1. All right, so this part, we have our x plus 2. Okay, if we don't see, if there's nothing we can factor out, always factor out a 1. So here we'd have plus 1 times x plus 4. Okay, that way when we factor out this GCF, we'll get x plus 2, and then we'd have 4x squared plus 1. Okay, this is why we have this plus 1, is so that you don't forget. All right, if you did it kind of the long way, where over in, I think it was A, then you should never have to worry about it. But kind of when we do this, make sure you factor out something, whether it be just a number of just 1, then it will still work out just good. Okay, D. All right, so here we have x's and y's, but still we'll cut it in half. Okay, for numbers, we can take out a 3. And for the variables, we can't take out any x's, but we could take out a y. So let's take out a y. We'd get 3y times x, because the 3 and the y would cancel out. And on the right side, we would get a negative 7. All right, right side we can factor out a 5, so we'd have plus 5. Divided by 5, we would get x minus 7. Okay, again, they're the same, so we did something right. So we get x minus 7 in one parenthesis, and the other would be 3y plus 5. All right, e, cut it in half. We can factor out an x squared, so we'd end up getting x squared times y minus 3. Here we can factor out a negative 8, so we'd have minus 8 times y minus, so remember, if we're dividing it by a negative, it's going to change all their signs, so we'd get a negative 3. Again, these are the same, so we'd get y minus 3 in one parenthesis, and then x squared minus 8 in the other. And finally, cut it in half. Hopefully you did some of this by yourself. Make sure you're feeling good. We can factor out a 2, and we can take out an x squared. So we'll have 2x squared times 4x plus 3. And then on this side, we would take out a negative, because it's a leading negative, would do a negative 6. Looks like we do a negative 6. So minus 6 times, well, negative 24 divided by a negative 6. That gives us positive 4x plus 3. Okay, again, those are the same, so we'd have 4x plus 3 times 2x squared minus 6. Okay, so that is grouping, and that's everything we've got for unit 3.1. If you have any questions, let me know. So just a quick review. Please always make sure it's in standard form, no matter what you're doing. In the future lessons, standard form always applies for everything, standard form. And don't forget, if it has a leading negative like a right here, we need to be factoring out the negative as well. Okay? All right, sounds good. We'll see ya.